Got to start my mic. Lol, I just started my intro. So, welcome back to Daily Calm. This is going to be a video on the coding on Minecraft. However, it's also going to be a series on binary logic, which is why I have a custom texture pack here. I actually need to replace that. I need to get rid of redstone overlay. Actually, I'll just do that quickly. Be right back. Send dust overlay, delete. If you don't know how to, if you just changed the texture pack and you want to do it, you don't need to close the game and reopen. Press F3T. Lags for a little bit. Not responding. I don't know if you guys can actually see this. Takes a little while. Of course, if I have Alienware, it takes like 2 minutes. There, 2 minutes, 2 seconds. Anyway, so which way is positive? Okay, so what I'm going to do. Alright, these maps are coming up. You'll see what they are. So, in the 1900s, it was long known that if you got a power source, you got a switch, and did that, it was long known that you'd end up with a redstone lamp that was on, or a light or something. Right? But what if you put 2 in a row? Like so, and then measure the output like so. What would you have then? Well, let's have a look, shall we? Not on. Still not on. They both need to be on. Oh, I forgot the one. They both need to be on for that to be on. See? See? This was the first ever AND gate. But what if you did this? Oh wait, no. Just need to do that and that and that. Get rid of that. Replace this. Yeah, I know the zeros and all that are wrong way around, but I can't help that. So what would you end up with here? This is an OR gate. However, the problem is these are moving parts and they're pretty big, aren't they? Seriously, these are about the size of your fist, right? And so how do they fit billions of these in your computer? They don't. They're not billions of solenoids, because that's what these are. They're billions of transistors. A transistor is essentially the same thing, except instead of having the solenoid piston, they actually have a slightly different thing. Let me just get some concrete. Actually, no, I'll use some stained clay. We'll use yellow and green and I might add a lever. Alright. So this is going to be a very, very bad demonstration. Alright, but what you'd have is something kind of like this. So that when the middle bit, the green bit, is powered, so this would be PCSN, or P-type silicon. This would be negative type silicon, and that's positive type silicon. Right? So you'd have positive, negative, positive. So only when it was powered, only when the gate was open, would electricity flow through? So what would happen is you'd end up with that, right? They'd stop here because they can't go through. Because it's silicon, it's a semiconductor. It only powers when it's got a electromagnetic current nearby. So basically the transistor was completely thrown out the window. And in its place came the transistor. Just before I forget. I'll just put these in the ground. There we go. So, it became the basis for the transistor. Now, the most simple gate, or transistor gate, was the OR gate. Let's have a quick look at it. It is quite literally just this thing. That is your most simple transistor. However, back in BC times, people were already working with binary, which is ones and zeros. And that's where these maps come in. F is false or 0. T is 1 or true. So, I need a item frame. Oh yeah, that's right, I named it selector. The reason why I call it selector is because if you don't know, you can actually do this. Pretty cool, though. And you can actually change the thing. But that's not what I'm here for. So, where's the item frame? Apologise, that's me. Yeah, so. What am I? So, let's just quickly make a little thing here. Now, a truth table looks like this. Ooh, item frame again. So, remember the OR gate, right? What did we have? We had false or false was false. And then we had false or true was true. True or false was true. And true, true. That's a truth table. You can do the same with AND as well. Go on the other side. Remember what we had? We had false and false is false. All truth tables follow the same pattern as that, and these are all unknowns. So we have AND gates. That symbol at the bottom, the little arrow pointing upwards, is the symbol for AND. Right? It's if you want to know what it is, it's wedge, also known as wedge. So you'll see some people put it as a dot, and some people put it as other things, but I have chosen to use the most simple. So we had false and false is false, false and true is false, true and false is false, true and true is true. So you see, it's kind of the opposite of a, it's the upside down version of an AND gate, but negated. If that makes sense.